Hello community, I could show you that we have a new ChatGPT for Omni, the latest version 0808, or that today there was a new Grok 2 published by Elon. And you see here we have now ChatGPT for Omni ranked number 1, Gemini 1.5 Pro number 2, then the new Grok 2 on rank number 3, then the Mini, then Claude 3 Sonnet, then we have Meta somewhere down the road, but no. Or I can show you here that today was published here by Google here, Imagen 3, the best diffusion model for text to image generation. But no, I would not like to be the public relation of the global corporation. I want to show you what the AI community is building, what universities are able to do, and they perform amazing tasks. So let's start today, the best 67 AI publications of today, Wednesday, and here we go. Towards autonomous agents, adaptive planning, reasoning, and acting in language model. And we have here University of Connecticut, beautiful. See here the architecture that we are talking about. In-context learning, large language model, natural language understanding, neural network, pre-trained model. We have the code available on GitHub, beautiful. So if you are into autonomous agent, look, they show us that even with a small model, a Gamma 2 9B instruction tuned, we can have some great achievements here. Or let's take the next one. Simple but effective compound geometric operation for temporal knowledge graph completion. We are here, Nankai University, Tianjin University of Science. Okay. So what we have here the code. This is beautiful, but we are talking about, give me a second. Temporal knowledge graph completion aims to infer the missing facts in temporal knowledge graph. Current approaches usually embed factual knowledge into continuous vector space and apply geometric operation to learn positional patterns in temporal knowledge graph. However, there's a problem, and therefore this research team proposes here a simple but effective method, a T compound E, which is specifically designed with two geometric operations, including time-specific and relation-specific operation. They provide a mathematical proof to demonstrate the ability to encode various relational patterns. Absolutely fascinating. I have to read this. Let's have a look at the next one. Enhancing visual dialogue state tracking through iterative object-entity alignment in multi-round conversation. Beijing, China. Okay, so we are talking about a visual dialogue, multi-round dialogue, state tracking, object entity alignment. Okay, is a task where an agent answers a series of image-related questions based on a multi-round dialogue history. So they have now the history memory integrated in this. Let's have a look at the next one. Personalized dynamic difficulty adjustment. Imitation learning meets reinforcement learning. What a beautiful title! Hannover, Deutschland. So we are talking about imitation learning, reinforcement learning, dynamic difficulty adjustment, fighting game AI. So balancing a game difficulty in video games is a key task to create interesting gaming experience for the player. And a mismatch in the game difficulty level and a player's skill level can cause some problems. Therefore, they explore balancing the game difficulty using machine learning-based agents to challenge a player based on their current behavior. And how they do this? They have a combination of two agents in which one learns to imitate the player, understand the level and the skill level of the player, while the second agent is trained to beat the first agent. So you see, what an intelligent idea to adapt here to the skill level of the individual player. Even more interesting, I think, is this one. Causal agent based on LLMs. And here we go. We have here, Huawei Technologies and Zhejiang University. Beautiful. Causal inference, causal discovery, LLM models and agent. And we have a GitHub code. Beautiful. And they say here, LLMs have a beautiful success, yes, but causal methods are not easily conveyed through natural language which hinders the LLM ability to apply them accurately. Causal datasets are normally tabular, while LLMs excel in handling natural language data. So this lack of causal reasoning ability limits the development of LLMs. And now they have equipped here an LLM with causal tools within an agent framework, named now the Causal Agent, enabling it to tackle causal problems. So the Causal Agent comprises tools, memory, and reasoning modules. I see what I did. So in the tool models, the agent applies causal methods to align tabular data with natural language. In the reasoning module, the causal agent employs the REACT framework, I have a specific video on this, to perform reasoning through multiple interaction with the tools. And in the memory model, the causal agent maintains a dictionary instance where the keys are unique names and the values are causal graphs. What a beautiful idea. You should have a look at this. I have to read this myself. The next one, decision-focused learning to predict action cost for planning. Planning, what a beautiful topic currently. Leuven, Belgium, Saarland University, Germany, beautiful. Here we go. We are talking about automated planning application. Action cost can be hard to specify. An example is the time needed to travel through a certain road segment, which depends on many factors such as the current weather conditions. Yes. Decision-focused learning has been successful in learning to predict the parameters of combinatorial optimization problems in a way that optimizes solution quality rather than the prediction quality. Now I get it. We investigate for the first time the challenges of implementing a decision-focused learning for automated planning in order to learn to predict the action cost. Planning systems are called during gradient descent learning to solve the planning problem with negative action costs, which are not supported. And DFL requires repeated planner calls during training, which can limit the scalability of the model. Interesting solution they found. Okay, next one. Automatic feature recognition and dimensional attribute extraction from CAD models for hybrid additive subtractive manufacturing. My goodness, what a title. So we are here into computer-aided design, computer-aided process planning, and computer-aided manufacturing. And there's a new methodology, beautiful hierarchical graph convolution neural network model is implemented to accurately identify the composite additive subtractive features within a synthetic CAD dataset. Automatic feature recognition, hybrid manufacturing, graph convolutional neural network, computer-aided design. If you're interested in this, look, there's even a conference at the end of August in Washington, D.C. Multi-agent continuous control with generative flow network. This is now a new topic. I like this generative flow idea. We are here at the Young University, Huawei's NOAA Arc Laboratory, Xi'an University, and let's make it a little bit bigger so you can watch it. Generative flow networks aim to generate diverse trajectories from a distribution in which the final state of the trajectories are proportional to the reward, serving as a powerful alternative to reinforcement learning for exploratory control tasks. However, the individual flow matching constraint in these networks limit the application for multi-agent system, especially here for continuous joint control problems. So they propose here a novel multi-agent, yippee, generative continuous flow network methodology to enable multiple agents to perform cooperative exploration for various compositional continuous objects. This is absolute nice. Manuscript version is available here. Okay, nice. Okay, if you are into a multi-agent here now with generative flow network, this is the paper for us. What a beautiful title. LLMs can schedule. We have here Paris, France, beautiful. The job shop scheduling problem. Oh yeah, remember. Remains a significant hurdle in optimizing production process, industrial production process. The challenge here involves efficiently allocating jobs to a limited number of machines, computers, while minimizing factors like total processing time or the job delays. So if you have a network, a cluster of compute infrastructure, and you have different jobs, how do you distribute those jobs on your hardware platform? Absolutely fantastic. And they explore the potential of LLMs for job shop scheduling problems. Absolutely interesting. Wow. New publication. Okay, let's have a look at the next one. Deep Learning Multimodal Transformer in Image Description. Okay. Northeastern University, Boston, Northeastern University, University of Houston. We are talking here about medical image recognition, the attention mechanism, deep learning. And they say zero sample learning is an effective method for data deficiency. The existed embedded zero sample learning methodology often used the known classes to construct the embedded space. So there's an overfitting of the known classes in the testing process. Most of the existing zero-sample learning algorithms directly use the depth feature of medical images as an input, and the feature extraction process does not consider other semantic information. And their project now intends to take here the ELMO MCT as the main task and obtain multiple visual features related to the original image through self-attention mechanism. Interesting. Medical image recognition optimized here. What an interesting topic. Let's go to the next one, IEEE. Oh, transcriptomics. Wow. Mass graph autoencoder with contrastive augmentation for spatially resolved transcriptomics data. My goodness, we have even the code for this. Domain identification, gene denoising. So if you're into transcriptomics technologies, this is the paper for you. Next one. Assessment of the CellNucle AI foundation model in kidney pathology. Kidney pathology, what a fascinating topic. Vanderbilt University in Nashville. Okay, University Medical Center. Crucial task. The segmentation is a crucial task in digital kidney pathology. Traditional automatic segmentation methods often lack generalizability when applied to unseen dataset. Yes, of course. The success of foundation models have provided a more generalizable solution. In this study, we perform a large-scale evaluation of 3 widely used state-of-the-art CellNucle foundation models. Now we have CellNucle foundation models in AI. You know, I am absolutely amazed what researchers built on top of our models. Let's have a look at the next publication of today. Virtual compiler is all you need for assembly code search. Tsinghua University. Okay. So assembly code search is vital for reducing the burden on reverse engineers, allowing them to quickly identify specific functions using natural language within vast binary programs. This paper explored training an LLM to emulate a general compiler by leveraging the Ubuntu package to compile a dataset of 20 billion tokens. We further continue pre-training a code llama as a virtual compiler capable of compiling any source code of any language to assembly code. What a beautiful idea. Okay, so if you're into compiler, this is definitely the paper for you. Autoregressive enzyme function prediction with a multiscale multimodal fusion model, Shanghai Jiao Tong University. Absolute fascinating. The function of enzymes, you have here this enzyme commission number. This is a long-standing descriptor, and they go about the accurate prediction of enzyme function is crucial. Deriving innovation from various sectors, predicting the EC number as a whole. We address here new methodology, a multimodal multiscale model designed to autoregressively predict the enzyme commission number of proteins. Fascinating idea. I learn every day. Next one. Design proteins using LLMs. Enhancement and comparative analysis by Siena, Italy. Beautiful. We explore the application of LLMs into generation of high-quality protein sequences. We adopt a suite of pre-trained LLM, a Mistral 7B, a Llama 3, and a Gemma 7B to produce valid protein sequences. All of these models are publicly available. Amazing! Here you can find all the models for the protein design. I think it's only fascinating. Okay, next one. This sounds interesting. Düsseldorf. Okay, Düsseldorf, Germany. Okay, distributed Stackelberg strategies in state-based potential games for autonomous decentralized learning manufacturing systems. What a beautiful title. Don't make it any shorter. Oh, I love this abbreviation. So you remember distributed Stackelberg strategies and state-based potential games? We have DS2-SBPG models. And if you want to find out about this in smart manufacturing, the application of game theory, Stackelberg games, energy optimization, and a multi-objective optimization problem in situ, combined with distributed learning, this is the paper for you. Wow. Now I really went here with biology and medical AI system. Protein function annotation for bacteriophagen by integrating the genomic context. City University of Hong Kong. Amazing idea. Bacteriophagen are viruses that target bacteria, playing a crucial role in microbial ecology. Phagen proteins are important in understanding phagen biology, such as virus infection, replication, and evolution. Accurate function annotation of phage proteins have several challenges, including the inherent diversity and the scarcity of annotated data. Nice. You see what people, the AI community is doing? This is so much more interesting if Google or, I don't know, Microsoft have published a new model. Next one, IEEE. Sounds interesting. A MultiView neural differential equation. Oh, for continuous time stream data in long-term traffic forecasting. Wow, this is nice. Long-term traffic forecasting, continuous time stream data and differential equation. Spatio-temporal streaming data, neural differential equation, long-term traffic flow forecasting. I think we do not have to say any more than this, and if you are working in this area, you will be delighted by those papers. Next one, decentralized cooperation and heterogeneous multi-agent reinforcement learning. What a coincidence that I started 2 weeks ago to show you the basic ideas of multi-agent reinforcement learning via graph neural network-based intrinsic motivation. University of Dhaka. Nice. Hello. Look, multi-agent reinforcement learning, yes, is emerging as a key framework for very sequential decision-making and control tasks. Development of these systems in real-world scenarios often requires decentralized training, a diverse set of agents, and learning from infrequent environmental reward signals. Yes, we propose a new algorithm which utilizes a novel graph neural network-based intrinsic motivation to facilitate the learning of heterogeneous agent policies in decentralized settings under the challenges of partial observability and reward sparsity. Wow, this sounds absolutely interesting. I have never heard here, Department of Computer Science and Engineering, University of Dhaka. Hey, great that you have published this new insights. Talking about new insight, we have here the next paper, Chain of Strategy Planning with LLMs. Aligning the generation of psychotherapy dialogue with strategy in motivational interviewing. Centrum of Wiskunde and Informatica in the Netherlands, and Shandong University, China. Amazon, Germany. Unbelievable. Yes, motivational interviewing. How to employ strategies, a set of motivational interviewing skills to generate therapeutic adherent conversation with explainability is underexplored. No wonder, I have no idea, I've never heard this before. So this research team proposes here an approach called strategy-aware dialogue generation with chain of strategy planning, which first predicts here the motivational interviewing strategies as reasoning and utilizes this strategy to guide the subsequent dialogue generation. Wow, absolutely fascinating here. Psychotherapy done by an AI system. If you think you have seen everything, you haven't seen anything at all yet. Okay, next one. Mixture of expert, Aquila, mixture of expert, efficient training for mixture of expert models with scale up and scale out strategy. Beijing Academy of Artificial Intelligence, Peking University, nice. Mixture of expert, efficient training, model initialization, and continuous pre-training. The rapid acceleration of LLMs across various fields, the scale of this model has gradually increased. Training of an LLM from scratch will cost a lot of computational resources. We present Aquila mixture of expert, a cutting-edge bilingual 8x16b mixture of expert language model that has 8 experts with 16 billion parameters each and is developed using an innovative training methodology called efficient scale, optimizes the performance by minimizing the data requirement, scale up, scale out. If you are into a mixture of expert system, this is the paper for you. And we're already here at the next paper, Perspective on LLMs, Intelligent Machines and Knowledge Acquisition, University of Minnesota. Okay. This is here the Turing test. We know of this. Hey, look, in the abstract, what really catched my attention here is the last sentence. We discussed the impact of LLMs on the acquisition of human knowledge and education. So, how do humans use LLMs to improve their knowledge, to have a better education, knowledge, utilizing LLMs? This is really hard to understand, but I wanted to show you that even, let's say, publication here with this kind of title that are rather general, intelligent machine and knowledge acquisition, what they really discuss here is the impact of LLMs on the human knowledge generation and acquisition. Therefore, I included it here in my list. And on we go to the next one, Generalized Knowledge Enhanced. You see we're in the same topic, framework for biomedical entity and relation extraction, University of Texas at Austin. Beautiful knowledge graph, information extraction, biomedical text for adverse drug effect identification. So we are here accelerating the growth in biomedical publication and the intricate nature of biomedical text, written formally for domain experts. Yes, of course. To handle those challenges, we develop a novel framework that utilizes external knowledge to construct a task-independent and reusable background knowledge graph for biomedical entity and relation extraction. Okay. So, if you're into biomedical text, this is the one for you. We continue here. My goodness, this looks strange. Whenever you have this, you understand that the people just want to fill here the pages because they are all here from the same company. Look, everything is here the same. So this is just to generate pages that you can publish. So we are talking about Meta. Now, what a coincidence! August 13, 2024. And we are talking about hierarchical structure neural network for retrieval optimization. Beautiful. Embedding-based retrieval is a crucial component of the retrieval stage in ads recommendation system that use here a Siamese network like sentence embedding. Then we have an approximate nearest neighbor to efficiently retrieve the most relevant ads for a specific user. I see why you, Meta, have this for Facebook and your other platforms. And they substitute now the approximate nearest neighbor search by a hierarchical structured neural network to deploy jointly optimized hierarchical clustering and a model that can take advantage of sophisticated interactions. Okay, and they achieve a 6% improvement and 1.2% online gains through the experiments. Meta, you can do better. Try next time. On we go. We are now here at the topic of analyzing the relationship between pre-training and fine-tuning. This is interesting of LLMs. Johns Hopkins University, this is interesting that they care about this. Pre-training process, supervised fine-tuning, instruction tuning, when, what, to what extent. So if you want to know how you best train your system, what is the optimal mix of pre-training and fine-tuning multiple intermediate pre-trained models, they have 18 datasets and they suggest, let me have a look. They had a question is, how do model pre-training and fine-tuning interact to affect the resulting model? Does more pre-training hinder better fine-tuning results? Or does the model learn and forget during pre-training as well as fine-tuning? And they did all this and they found out, where is it? Our experiment yield insight into LLM training. We find that continued pre-training can improve the model in ways that are often revealed after fine-tuning. Tasks for which the model already performs well during the pre-training benefit much less from fine-tuning than those where the model does not demonstrate those capabilities. Although supervised fine-tuning can improve performance on in-distribution tasks, it can also cause the model to forget domain knowledge or tasks that it was previously capable of solving. So here again, in-distribution task and the established domain knowledge. Be careful about this. I have multiple videos on this. Fine-tuned models show a high sensitivity to relation prompts, but this sensitivity can be alleviated by more pre-training. So this is nice. This is definitely a study to look at if you want to know the right equilibrium between supervised fine-tuning, instruction tuning, and pre-training fine-tuning. Absolute fascinating topic. And we go on to the next one. Here we have a robust approach to structural attacks via negative sampling. Hello, China University of Geosciences. This is interesting. Node classification using graph neural network has been widely adapted. Yes, however, recent studies have shown that graph structured networks often contain potential noise and attacks in the form of topological perturbations and weight disturbances, which can lead to decreased classification performance in graph neural network. We propose a novel method, random walk negative sampling graph convolutional networks. Wow, so if you are into graph convolutional networks and random walk application, this is the paper for you. Let's have a look at the next one. Leveraging priors via diffusion bridge for time series generation. This is interesting. Seoul National University. Time series generation is widely used in real-world applications such as simulation, data augmentation, and hypothesis testing. Diffusion models have emerged as the de facto approach for time series generation, emphasizing here the synthesis scenario based on historical or correlated time series data streams. And here we propose Time Bridge, a framework that enables flexible synthesis by leveraging different diffusion bridges to learn the transport between chosen prior and data distribution. This sounds absolutely fascinating. We have to have a close look at this publication. And on we go. Talking about diffusion models, we have now diffusion classifier for three-dimensional objects. Max Planck Institute for Intelligent Systems in Germany, and everybody else, Stanford University and University of Amsterdam and Google and Switzerland, and beautiful. So we have a GitHub code for 3D building classification, and they say here, we explore the use of 3D diffusion models for object classification. Leveraging the density estimates from this model, our approach enables zero-shot classification of 3D shapes without additional training. This is nice. Our model achieves an average 12.5% improvement compared with MultiView counterparts. And our next paper is computational friendly graph neural network design by accumulating knowledge on LLMs. Hong Kong University of Science and Technology, beautiful. Graph neural networks have here shown remarkable success, but are hampered by the complexity of their architectural design, which depends heavily on specific data and tasks. To reduce the human workload, researchers tried to develop automated algorithms to design graph neural networks. Okay, so what they did, they invented some more. Our framework begins by establishing a knowledge retrieval pipeline that comprehends the intercorrelation between graphs, graph neural network, and performance. This pipeline converts past model design experiences into structured knowledge for LLM reference, allowing it to quickly suggest initial model proposal. We introduce a knowledge-driven search strategy that emulates the exploration process of human experts, enabling quick refinement of initial proposal within the promising scope. Okay, if you are into this, this is your publication of today. And we go on. Department of Mathematics in Sweden. Yes, absolutely. Czech Technical University in Sweden. Uddeholms AB. Okay. Adaptive Data Quality Scoring Operation Framework using drift-aware mechanism for industrial application. Look, this is so nice if you have keywords. Industrial application, adaptive data quality scoring, data validation, data-driven AI, and in general drift detection. You know exactly what this is all about. You have here the abstract, very nicely structured, within data-driven AI systems for industrial application, ensuring the reliability of the incoming data stream is an integral part of trustworthy decision-making by our AI. An approach to assess the data validity is data quality scoring, which assigns a score to each data point or stream based on various quality dimensions. In this paper, we introduced the Adaptive Data Quality Scoring Operation Framework, a novel framework developed to address the challenges posed by dynamic quality dimension in industrial data streams. Environment, and the next one is LLMs can consistently generate high quality content for election disinformation. You are shocked? Who would publish this? My goodness, look at here all the authors. Conceptualization, methodology, investigation, resource, software, data curation, writing, reviewing. My goodness, who is doing this? Oh, United Kingdom here. Alan Turing Institute, the Research Engineering Group, Oxford Internet Institute. Wow, so if you are interested here in election disinformation operation, you have here a beautiful publication as published today. What is nice? DiffLoRa, generating personalized low-rank adaptation weights with diffusion. You see, diffusion is everywhere today. University of Electronic Science and Technology of China, Hainan University, real nice. Thank you for the visualization. We propose DiffLoRa, a novel approach that leverages diffusion models as a hypernetwork to predict personalized low-rank adaptation weights based on the reference images. I see what they do. By integrating these LoRa weights into the text-to-image model, DiffLoRa achieves personalization during inference without further training. What a beautiful idea to implement this. And on we go. Evaluating research quality with LLMs and analysis of ChatGPT's effectiveness of different strategies and input. University of Sheffield in the UK. And we are talking about evaluating the quality of academic journals. Oh wow, now we do not have human evaluation of our scientific work, but now we have ChatGPT produce better quality score estimates. Okay. Scientometrics, research assessment. So if you are into scientometrics, I've never heard before this word, then this was the paper for you. Hey, what a beautiful paper. You see, this is an image I love. Cross-view geolocalization and disaster mapping with street view and satellite imagery. A case study of a Hurricane Ian. This is nice. This is here, Technical University of München. Yes, okay. China, University of Texas at Austin. Tongji University in Shanghai. Cross-view disaster response, geo-AI systems, human-urban interaction, street view imagery, geolocalization, contrastive learning. This is a very useful application of our AI, of our intelligent quotation mark, if we want to here have a faster and better disaster response given a specific hurricane, for example. Definitely have to read this paper in detail. Okay, and here we go on exploring domain shift. Domain shift we had in my last videos on radar-based 3D object detection amidst diverse environmental condition. We have here our researcher from Bosch, Germany, and University of Stuttgart. Beautiful. And we are talking here about rapid evolution of deep learning. Its integration on autonomous driving system has led to substantial advancement in 3D perception using multimodal sensors. Radar sensors show greater robustness compared to cameras and LiDAR under adverse weather and varying illumination conditions. This study delves into the often overlooked yet crucial issue of the domain shift in four-dimensional radar-based object detection in examining how varying environmental conditions such as different weather patterns and road types impact the 3D object detection performance. Real nice, an important study that we can use immediately in all our cars. Beautiful. Next publication. Yes, we are warming up. Cross-domain feature fusion and multi-attention speech enhancement network based on a self-supervised embedding structure. And you might say, what a beautiful title. And this was done by Natural Science Foundation of China. Beautiful. And Xinjiang University, China. Beautiful. So speech self-supervised learning has achieved here state-of-the-art performance in multiple downstream tasks. However, its application in speech enhancement tasks remains immature, offering opportunities for improvement, and they introduce a novel cross-domain feature fusion and multi-attention speech enhancement network, which leverages self-supervised embeddings. Wow, if you're into speech AI, we have found your paper of today. And on we go. No, this was the wrong one. Sorry, this was the wrong one. Achieving fairness in bias-based weight masking fine-tuning. I have no idea what this is all about. Let's have a look at the University of Edinburgh here. So we go here, developing model with robust group fairness property is paramount. Recent approaches in achieving fairness in machine learning requires a substantial amount of training data. We propose here a bias-based weight masking fine-tuning, a novel post-processing methodology that enhances the fairness of a trained model in significantly fewer epochs without requiring access to original training data. It produces a mask over model parameters which effectively identifies the weight contributing the most towards the bias prediction. I see what they do, and we have the GitHub code available. So if you are into bias identification and bias removal, then this is the paper for you. For the rest of us, we just go on because we want to learn more about heterogeneous space fusion and dual dimension attention, a new paradigm for speech enhancement. No, Jesus, I found here this paper, and I listed it right after the other paper on AI speech enhancement. So congratulations, you have found 2 papers here on my channel today. Next one is heavy ball momentum accelerated actor critique with function approximation, IEEE paper. Actor critique algorithms we do know, but what is the momentum? By using a parametric value function to replace the Monte Carlo rollouts for value estimation, the actor critique algorithms, I have a video on this about 2 weeks ago, can reduce the variance of stochastic policy gradients to improve the convergence rate. We first propose a heavy ball momentum-based advantage actor critic algorithm by integrating the heavy ball momentum into the critic recursion that is parameterized by a linear function. When the sampled trajectory follows a Markov decision process, we quantitatively certify the acceleration capability of the proposed algorithm. Wow, sounds interesting. I have no idea how they do this, but it is about the actor critic algorithm, and they introduce now a new dynamic term, the momentum, into their calculation. Let's go on and let's have a look at the next one. We are talking about generative AI for automatic topic labeling. Hey, this is a simple topic. I understand what it's all about. We have here Montreal, University of Montreal, Canada. Beautiful. Topic modeling has become a prominent tool for the study of scientific fields as they allow for a large-scale interpretation of the research trends. Yes. So what you have found, we assessed the outputs and found first, GPT models are capable of accurately and precisely labeled topics from the model's output keywords, and second, 3-word labels, are preferable to grasp the complexity of research topics. So if you're looking here for specific keywords, don't look for a single keyword, but go for a 3-word, if you want, label or keyword. So you have a much better distinction here of your research topic. Nice to learn this. Okay, our next paper is here on Path Insight, Instruction Tuning of Multimodal Dataset and Models for Intelligence-Assisted Diagnosis in Histopathology. My goodness! Medical topic, histopathology, absolutely important here. It remains the definitive standard for identifying tumors. And the rise of multimodal LLMs has simplified the process of integrating image analysis with textual description, and they deployed here in a clinical setting with trained on 45,000 cases. They fine-tuned the LLM model, specific here dose, with a dataset to enhance here the instruction-based performance. And then they have a qualitative assessment of theirs. So we are talking here about computational pathology. I am fascinated by this topic. Amazing where our AI community is applying AI models. But before we get too fascinated by this, we go on a survey on model merging, a mixture of expert merging, recycling, and routing among specialized experts for collaborative learning. Okay, we know where we are. University of Toronto, MIT, IBM, Microsoft Research. My goodness. You see, industry is interested in this topic here. A key component of mixture of expert merging methodologies is the creation of a router that decides which expert model to use for a particular input or application. The promise, effectiveness, and the large design space of mixture of expert merging has spurred the development of many new methods over the past few years. Rapid pace of development has made it challenging to compare it. To remedy such gap, we present a comprehensive survey of mixture of expert merging methods that includes a novel taxonomy for cataloging key design choices and clarifies sustainable application for each method. Sounds absolutely fascinating. Model counting in the wild. Mathematical Institute, India, Calcutta. Yeah, nice. Hello, friends in India. Given a Boolean formula f, often presented in conjunctive normal form, the problem of model counting is to compute the number of solutions of the formula. Model counting is a fundamental problem in computer science and has been studied by theoreticals and practitioners alike for the past 4 decades. And now for the p-completeness, they have some solution with AI. Okay, we have to deep dive. There's no way I can summarize this without having really read here the publication. But luckily, we have the next one that seems rather easy. Does liking yellow imply you are driving a school bus? Semantic leakage in language model. This is simple. This is beautiful. Paul Allen School of Computer Science, University of Washington, Allen Institute for AI. You see here what they call semantic leakage. So if you have a prompt, he likes yellow, he works as, and then the AI has here to come up with the next word. Yellow and work. So the first association here in the distribution, the probability distribution here, is school bus driver. Good, beautiful. He is a doctor. His favorite song is Staying Alive. Real funny by the Bee Gees. So, okay, we know what this is all about. We continue because we want to learn more. We are now absolutely fascinated. And you say, hey, Spark or a retrieval augmented knowledge service system based on Spark large language model. This is nice. Research China, Institute of Technology China, Chinese Academy of Sciences China, beautiful. LLMs achieved something beautiful to enhance the performance of LLMs in scientific literature services. We develop a scientific literature LLM. Yes, through pre-training and supervised fine-tuning on scientific literature, building upon Spark LLM. We present a knowledge service system, Spark Research Assistant, based on our LLM. It is accessible online and it has already a lot of users, so why not give it a try? Try it out yourself. The next publication is about a new benchmark dataset for cyber threat intelligence summarization. Beijing's China. Okay, we are talking about natural language generation of information system, cyber threat intelligence. Summarization task required a system to generate concise and accurate highlights from raw intelligence data, which plays an important role in providing decision makers with crucial information to quickly detect and respond to cyber threats in the cybersecurity domain. We present CTA Sum, a new benchmark for CTI summarization task. Considering the importance of attack process, a novel fine-grained subtask of attack process summarization is proposed to enable defender to assess the risk, identify the security gaps, the IT vulnerabilities, and so on. We first design a multi-stage annotation pipeline to gather and annotate the CTI data and then benchmark with a collection of extractive and abstractive summarization methodologies. Nice. Okay. So a lot of research currently is done on the cyber threat intelligence. Interesting. So on we go. We jump to our next one. My goodness. Fast and frugal text graph transformers for effective link prediction. Leuven, Belgium Research Institute. Link prediction model can benefit from incorporating textual description of entities and relations, enabling full inductive learning and flexibility in dynamic graphs. We address the challenge of also capturing rich structured information about a local neighborhood of entities and their relation. Nice! By introducing a transformer-based approach that effectively integrates textual description with graph structure, reducing their reliance on resource-intensive text encoders. Hey, this sounds real nice. I definitely have to read this one. But there's no time because we have to go unlock the power of frozen LLMs in knowledge graph completion. You see, knowledge graph is another hot topic. Shanghai, China. Classical knowledge graph completion methods rely solely on structural information, struggling with the inherent sparsity of knowledge graphs. We aim to leverage LLMs for classical knowledge graph completion effectively and efficiently. We capture the context-aware hidden state of knowledge triplets by employing prompts to stimulate the intermediate layers of LLMs. We then train a data-efficient classifier on these hidden states to harness the inherent capabilities of frozen LLMs. This sounds nice. We have to read this definitely here quietly at the weekend. Absolutely fascinating topic. But I know you're interested in more and you say, what else was published today? And we are talking now about a layer-wise recurrent router for a mixture of expert. You see, MOAs are still hot. Tsinghua University, University of Edinburgh, Nanjing University, University of Amsterdam, Shanghai AI Lab, beautiful. And we have the code on GitHub. So we introduce a layer-wise recurrent router for a mixture of experts. Leverages here a gated recurrent unit we noticed from years ago to establish dependencies between routing decision across consecutive layers. Such layer-wise recurrence can be effectively parallelly computed for input tokens and introduces negotiable costs. Okay, we have to look at this in detail. Sounds absolutely interesting. Layer-wise routing. You might say, do we have more? Yes, LoRa squared, multiscale low-rank approximation for fine-tuning LLMs. Shanghai University of Engineering Science, Shanghai, China, beautiful. We extend the LoRa to multiple scales, dubbed as LoRa squared. We combine orthogonal projection theory to train a set of LoRas in two mutually orthogonal planes, okay? Because this makes it a lot easier, then we improve the importance core algorithm, which reduced parameter sensitivity score calculations by about 98% by pruning now singular values with low importance score, thereby enhancing adaptability of various downstream tasks. Validate effectiveness. Okay, we have to have a look at the code. Beautiful, it is there. Because just given here the summary, I do not really understand what they have on their orthogonal planes. I suppose they are hyperplanes, but we have to read this to really understand what's going on here. Absolutely different to this beautiful title that explains it immediately. We are here in medical image segmentation, and we have an SVD-based fine-tuning of segment anything model, our SAM model. I suppose they still go with SAM1, you know, Johns Hopkins University, Baltimore. We have now SAM2. Medical image segmentation, traditionally approached by training or fine-tuning the entire model to cater to any new modality of the dataset. In this paper, we propose an adaptation technique called SSAM that only trains parameter equal to 0.4% of all the SAM's parameter, and at the same time uses simply the label names as prompts for producing precise mask. Okay, I get the idea. And we have a GitHub repo. Yeah. We have to have a look at this. This sounds absolutely fascinating. But on we go, because there was so much interesting things generated by the scientific community today. Unleashing 10,000 plus words generation from long context LLMs. Long context LLMs can process up to 100,000 tokens, up to 2 million tokens. If you go to Google, to reintroduce Agent Write, an agent-based pipeline that decomposes ultra-long generation tasks into subtasks, enabling off-the-shelf LLM to generate coherent output exceeding here the typical 20,000 words. Okay, so it's just the writer LLM. Nice. We go to the next one. In-domain feature adaptation via action cues for video temporal grounding. Video temporal grounding. This sounds interesting. Need to find sequences in our video sequence. Video temporal grounding is an emergent topic aiming to identify specific clips within videos. In addition to pre-trained video models, contemporary models utilize pre-trained vision language model to capture detailed characteristics of diverse scenes and objects from video frames. Yes. We introduce action cue injected temporal prompt learning, which injects action cues into the image encoder of the VLM for better discovering action-sensitive patterns. I see what they do. Yes, okay. Next one. Hey, we have here a beautiful application for AI, a unified seismic natural network for single-station, real-time earthquake early warning system, an early warning detection system. Shanghai University of Intelligence, Chinese University, Hong Kong. Beautiful. This is really, what a beautiful idea to use AI here for earthquake early warning to detect here the patterns. Next one is high quality object detection. Okay. Beihang University. Object detection is important. As a key to model training, intersection overunion greatly shows the difference between current prediction box and the ground truth box. Okay, I see what they do. Yes, this is nice. So, multimodal analysis of white blood cells. Okay, medical application, differentiation in acute myeloid leukemia patients using a beta variational autoencoder. Helmholtz-Zentrum München. AI for Health, Information Computer Science, Trento, Italy, University of München, Department of Chemistry, University of München, Johns Hopkins University, Baltimore. Biomedical imaging and RNA sequencing with single-cell resolution improves our understanding of white blood cell diseases like leukemia. By combining morphological and transcriptomic data, we can gain insight into cellular function and trajectories involved in blood cell differentiation. Existing methodologies struggle with integrating morphological and transcriptomic data, leaving a significant research gap. We introduce an unsupervised method that explores and reconstructs these two modalities and uncovers the relationship between different subtypes of white blood cells from human peripheral blood smears in terms of morphology and the corresponding transcriptome. Our method is based on beta variational autoencoder, which customizes a loss function, incorporated a CNN architecture to distinguish single cell from background and to minimize any interference. Sounds fascinating. Fascinating here. Variational autoencoder here for this. Okay, I have to have a look at this paper. Sounds absolutely interesting. Multimodal analysis of white blood cells. I find it amazing, what universities and hospitals and researchers find here application areas for artificial intelligence. Absolutely. I find this so much more valuable for AI to do something real good to humanity, or if Google announced a new LLM. But no time to waste. We go on long-tailed out-of-distribution detection, prioritizing attention to tail. I have read about this already. Xiamen University, out-of-distribution, typically assume balanced in-distribution data. Yes, I know what they're doing here. It's an interesting article. Have definitely a look at this one. And we go on to Reclip Plus, learn to rectify the bias of clip for unsupervised semantic segmentation. Yeah, I know what this is about. Previous work doesn't explicitly model the bias, which largely constrains the segmentation performance. We propose to explicitly model and rectify the bias existing in CLIP to facilitate the unsupervised semantic segmentation task. Okay, yes, let's go on, because there's so much more interesting stuff. Flat Fusion, delving into details of sparse transformation-based Camera-LiDAR Fusion for autonomous driving. Camera-LiDAR Fusion for autonomous driving, real nice. Shanghai University, Carnegie Mellon University. We have diverse sensor modalities, camera and LiDAR. Recent advancement in efficient point cloud transformers have underscored the efficiency of integrating information in sparse format. When it comes to fusion, such image patches are dense in pixel space with ambiguous depths. It necessitates additional design consideration for an effective fusion. We conduct a comprehensive exploration of design choices for transformer-based sparse camera LiDAR fusion, encompassing strategy for image to 3D and LiDAR to 2D mapping. Absolutely fascinating. We introduce Flat Fusion, a carefully designed framework for sparse camera LiDAR fusion. Wow. You see, this is what I find interesting. The intelligence that went into combining here different sensor arrays and using AI for the process. But on we go. Next one is highlight a comprehensive survey of synthetic infrared image synthesis. Yeah, I've chosen this paper because right after LiDAR and camera data, there's now a new survey for infrared image synthesis. So if you're interested here, particularly working with infrared scene simulation tools, this is the paper for you. For the rest of us, we switch over to robotics, and we have here FedRobo, Federated Learning Driven Autonomous Inter-Robot Communication for Optimal Chemical Sprays. The first time I read this, I had no idea what it is all about. But I can tell you it is simply about fertilizer for your crop. So you have federated learning enables robot to learn from each other experiences without relying on centralized data collection. Each robot independently maintains a model of crop conditions and chemical spray effectiveness, which is periodically shared with other robots in the fleet. And a communication protocol is designed to optimize the chemical spray application by facilitating the exchange of information about crop condition, the weather, and other critical factors encountered by each single robot. And the federated learning algorithm leverages this shared data to continuously refine their optimal chemical spray strategy, thereby reducing waste and improving here the crop yield. Very intelligent application of AI. Yes, absolutely. Multi-robotic system that can communicate about their experience. And federated learning. Now we go to operator learning using random features, a tool for scientific computing. And you know I had to have a look at this. So we are looking here at scientific machine learning, operator learning, random features, surrogate model, kernel-rich regression, parametric partial differential equation. My tongue is breaking away. But yeah, you have an idea what this is all about. And then we go here to the next one. We are here at Indian Institute of Technology and Purdue University. Beautiful. We have here in-memory computing architectures for deep learning accelerators, leverage energy efficient and highly parallel matrix vector multiplication operation, implementing directly in the memory arrays, and they found here a new better way to do this for in-memory computing, deep learning, low power, and mixed signal. So if you are into in-memory computation optimization, this is the paper for you. So what else I found? A library for visuotactile sensor simulation and learning. So in my words, how strong a robotic arm can grasp here a specific object. The sense of a touch, known as tactile sensing, is critical for performing contact-rich manipulation tasks. You have the robotic tactile sensing interpreting the sensor signal, generating a sensor signal for novel scenarios, and learning sensor-based policies, based here only on vision sensors or GB cameras. We present a library for GPU-based visotactile sensor simulation and learning. Can be used to simulate visotactile images and extract contact force distribution. Beautiful, beautiful, beautiful. You know, if you are working in this field, that you want to know more about this. This I've chosen for a particular reason. Let me show you. And this is here. Yeah, swarm robotics. I think I have not talked about swarm robotics in any way enough, because here the communication between a set of robots or a set of agents with different devices will be of extreme importance in the future. So decentralized controlled here for swarm robotics. If you are into multi-robot covering and ground robots here under some supervision, you should have a look at this particular paper. And the last paper, hooray, hooray, for today that I found that is so interesting that I have to show it to you, is here by the Department of Traffic Engineering of Road and Safety Engineering here from Tongji University in Shanghai. A multi-agent, yes, it's always now a multi-agent. We do not have solo agent anymore. A multi-agent proximal policy optimization method with prior intent sharing for cooperative decision making. And the first time I read it, I said, what is intent sharing? But if you read the abstract, you understand immediately. Vehicle-to-vehicle technologies have a great potential for enhancing the traffic flow efficiency and the safety. However, cooperative decision-making in multi-agent system, particularly in complex human-machine mixed merging areas, remains challenging for connected and autonomous vehicles. Intent sharing. Hey, I would like to make a left turn. Hey, maybe I should make a right turn at the next traffic light, is a key aspect of human coordination, may offer here an effective solution to these decision-making problems, but its applications here is underexplored. And they present here an intent-sharing-based cooperative method, the multi-agent proximal policy optimization with prior intent sharing. My goodness, so we integrate now the human intent sharing now in the decision-making of our multi-agent system. Isn't this fascinating? And yes, I would like to end here this video with a topic that we have at the very first information point of this video. And if you look here, the latest ChatGPT for Omni model here, given here the latest version 0808 now beats in coding here Claude 3.5 Sonnet. And if you look here at Sonnet and here at ChatGPT, the latest, you see, based on all the other models here, the latest update of ChatGPT for Omni seems to be quite significant in the coding arena. This was it for today. This was Wednesday, and yes, I know you are waiting for Thursday, but give me a day, because sometimes I have to read, sometimes I have to sleep, but yes, you can look forward to Thursday edition.